These are questions humanity has likely pondered since the dawn of time. How did the universe originate? What existed before it? And are we truly alone in the cosmos? The James Webb Space Telescope was launched to help us uncover answers to these profound mysteries. But instead of merely confirming what we already suspected, this most advanced space observatory is challenging almost everything we believed about the universe's formation. Webb has uncovered vast cosmic structures that astronomers are calling impossible, features that shouldn't even exist according to our current models. So how do we respond when confronted with discoveries that defy the very foundations of modern cosmology? Can our long-standing theories still hold up when faced with such contradictions? Or, more provocatively, could it be that the universe didn't actually begin with the Big Bang? Stay with us until the end as we dive into this fascinating cosmic mystery. Even if you're not a space enthusiast, chances are you've heard about the technological marvel that is Webb, and it's changing everything we thought we knew. Equipped with a 6.5-meter primary mirror and 4 advanced infrared instruments, the James Webb Space Telescope stands as the largest and most powerful space observatory ever built. In some cases, it is up to 100 times more sensitive to electromagnetic radiation than its predecessor, the Hubble Space Telescope. Engineered specifically for infrared astronomy, Webb is designed to revolutionize our understanding of the universe's structure and formation. It will explore the birth and evolution of galaxies, stars, and black holes, and study distant exoplanets for signs of habitability. Moreover, Webb will peer back in time to observe the first luminous objects and galaxies that emerged after the Big Bang, during the so-called cosmic dark ages, nearly 13.5 billion years ago. But what happens when even our most sophisticated theories are challenged by the very discoveries we hoped they would explain? When Webb uncovers something so unexpected, so bewildering, that it sends shockwaves through the scientific community. It wouldn't be the first time our understanding of the cosmos has been shaken. History reminds us that humans once believed Earth was the center of the universe. Even Einstein, convinced the cosmos was static and unchanging, introduced the cosmological constant to support that idea. Today, we understand that Earth is just a small fragment of a vast, and possibly infinite, cosmic structure. And despite all we've learned, we may still be only scratching the surface of the universe's true nature. After Einstein came to terms with the fact that the universe has been continuously expanding since the dawn of time, he famously referred to his cosmological constant as the greatest blunder of his life. Despite many unanswered questions and failed attempts to fully understand the cosmos, some truths are now firmly established. Most astronomers agree that the universe began 13.8 billion years ago with what we call the Big Bang. However, unlike the common misconception, the Big Bang wasn't a violent explosion in pre-existing space. Instead, it marked the rapid expansion and birth of space itself, emerging from an incredibly hot and dense singularity. From this tiny starting point, space, time, and matter all came into existence. But how do we know this today? The answer lies in tracing the very phenomenon Einstein once rejected, the expansion of the universe. By observing how the universe continues to stretch outward, scientists can work backward to a point where matter and energy were infinitely dense and spatial dimensions were effectively zero. It's important to note, though, that Big Bang theories don't explain the exact moment the universe was born. Rather, they focus on the immediate events following its creation. One of the strongest pieces of evidence supporting the Big Bang theory is the discovery of cosmic microwave background radiation, an ancient echo of the universe's fiery beginnings. This nearly uniform relic dates back to a time when the universe was just 380,000 years old, and remarkably, it still fills the entire cosmos today. But when it comes to the structures that emerged shortly after the Big Bang, one core assumption remains: the first galaxies were expected to be small. Most astronomers agree that the first stars appeared around 200 to 300 million years after the universe began. Yet, exactly when those stars formed into galaxies, and how rapidly those galaxies evolved, remains a mystery we've yet to solve. One thing is clear: Astronomers using the James Webb Space Telescope have identified several galaxies that formed just 300 million years after the Big Bang. As expected, initial spectral analysis showed these early galaxies were small and low in mass. But then came a startling twist. 6 newly discovered galaxies from the same era defied all existing models. Despite their ancient age, they appeared to be nearly as massive as our present-day Milky Way. Astrophysicist Evo Lab, a member of the research team, recalled his initial shock. "I ran the analysis software and got 2 numbers, distance, 13.1 billion light-years, mass, 100 billion stars. I nearly spat out my coffee. We had just found something that shouldn't exist, massive galaxies forming impossibly early in the universe's history." Lab and his colleagues at Swinburne University of Technology in Melbourne analyzed several images captured by the Near-Infrared Camera, NIRCam, aboard the James Webb Space Telescope, as part of its early release program. These images focused on a region of the sky near the Big Dipper, an area already studied by the Hubble Space Telescope and widely regarded as a window into the universe's dawn. During their deep analysis, the researchers spotted several reddish, glowing points of light. Their distinct properties indicated extreme distances and incredible age, confirming these were among the earliest and most massive galaxies ever observed. By analyzing redshift data, researchers determined that the light in question took over 13 billion years to reach Earth. This means it originated from celestial objects that existed just 500 to 700 million years after the Big Bang. Further examination revealed that the sources of this ancient light were 6 extremely early galaxies. However, instead of the small, developing galaxies scientists had expected to find, they were met with fully matured galactic giants, far beyond what current theories predicted. The data showed that each of these galaxies contained more than 10 billion solar masses of stars, with one possibly nearing a staggering 100 billion solar masses. Joel Leha of Pennsylvania State University, a member of the research team, was initially so surprised by the results that he suspected an error in the analysis. Yet, repeated checks confirmed the data's accuracy, there was no mistake, and the mystery persisted. The researchers' last hope for resolving the puzzle lay in the possibility that these structures might not be galaxies at all. Instead, they could be massive, dust-shrouded black holes masquerading as galaxies, offering at least a partial explanation for the unexpected findings. However, this would imply that the early universe contained far more stellar material than scientists had previously believed. Regardless of the explanation, Webb's discovery starkly contradicts almost every widely accepted model of cosmology. And the reason is quite simple. Based on our current understanding, there simply wasn't enough ordinary matter back then to form so many stars so quickly. Erica Nelson, a co-author of the study, remarked, "Even if just one of these galaxies is real, it challenges the very limits of our cosmological understanding." These so-called universe breakers were only the beginning. To account for the existence of these galaxies, we must either accept that the density of matter in the early universe was 2 to 5 times higher than our current models predict, or that galaxies formed through mechanisms we have yet to comprehend. Either possibility forces scientists to rethink the foundations of cosmic evolution. Unsurprisingly, these enigmatic structures have earned the nickname universe breakers, as they call into question what was once considered settled science. It now appears that the stellar mass present during this early cosmic era may have been up to 100 times greater than previous models indicated. Until recently, cosmologists believed that galaxies began as small clouds of stars and dust, gradually growing over time. But is that the only path to galactic formation? Even American astrophysicist John Cromwell Mather, who has dedicated his entire career to NASA, admits that he and his colleagues have hit a dead end. He reflects, people want answers. They ask, what have you discovered? And the unsettling truth is, the first galaxies didn't evolve the way we predicted. Why those early models failed remains a mystery. As surprising as this discovery is, it's only the start of a much deeper, and far more perplexing, astronomical journey. Since then, the James Webb Space Telescope has uncovered even more objects that defy our current understanding. Among them are ancient galaxies that are not only massive but also remarkably well-structured, far more advanced than they should be for their age. Even more astonishing are hints of galaxies with extremely high redshifts, possibly formed when the universe was still cloaked in darkness.